Good morning, everyone. How did the review goes? So the goal today is to answer all your questions about the review and about the material we're covering before your exam tomorrow. I hope you guys have started the review. So any questions about yesterday homework first, and then any questions about the review. So yesterday's homework, any questions about that? Patrick, number 17. And Neely, number 87. Okay. And 87. So this is, I imagine, those are from the book. So we look at them, and then I will take 86, 87. So you guys asking the same type of questions. 16A, and I did not understand the 15. I didn't understand what this means. 15M. Okay. So okay, so which one from the review? Is 17, 87 and 86, those are from the book. Are the other ones from the book, from the review? Okay, okay, all right. So, and how about 17? Is it from the review as well? So let me start first in the book so I don't get confused, and then I will go back to the review and we'll do those. Okay, so the book first, which is, I imagine, was 87, 86, and then I will go back to the review. All right. So 87 and 86. We start with 86, and the question is, make a possible graph of a function that satisfies all of the given conditions. Okay, so we want a function that satisfies the following condition. It takes -1 to -2. It takes 1 to 2. It takes 0 to 0. And then limit as x goes to infinity of f of x is 1. And the limit as x goes to -infinity of f of x equal to -1. Okay, so we want a function that satisfies all of the following conditions. All right, so we wanted to take -1 to -2, 1 to 2, 0 to 0. And okay, now this is limit as x goes to infinity is 1. It means we definitely tells me that y equal to 1, because that's an end behavior, is a horizontal asymptote. And this tells me again that y equal -1 is a horizontal asymptote. So we really have two of them. So, okay. How shall we graph this type of function? Okay, I want -1 to go to -2. So -1 have to go to -2. I want you guys to draw it with me. So here, at 0, I want it to be 0. At 1, I want it to be 2. So this is 2. And now, when x goes to +infinity, so when x keep increasing without bound, I want the function, the output, to become close to 1. So I want it to be here when x grows to infinity. And when x grows to -infinity, so I want it to be, so when x is here, that's the other end behavior, I want the output close to -1. So this is -1, this is 1. I want the function to be here. So how can I draw this function? Anything. I mean, you guys will have to draw the graph. Okay, so I want this output, this output, this output, and then I want this. How can I do it? Was anyone able to sketch this graph? Anyone is able to do it on a piece of paper? I can see I did, but I'm not sure how to explain it. All right, I don't. Can you pin yourself, Elizabeth, using the Zoom? Can you try to pin yourself? See if you can show us the picture. Well, let me see if I can pin you. You understand what I said, Elizabeth?
I don't know how to do that, but what I did.
There are three dots. There are three dots.
Yeah, what I did is I went through all 3 points and did.
Okay, I try to follow you. I'm gonna start here.
Go up through the next 2 points.
Uh-huh.
And then the next one. And I made like a curve that goes down towards the asymptote.
Very good. You see what she's telling me. Okay, how about the other piece?
I did the same thing except going up towards the asymptote.
Perfect. Okay, so that's how we're gonna sketch this type of function. All right, we'll do 87, and I'm gonna give you also time to be, I meant whatever, 88, I guess. And then I also wanna give you time to be able to interact with the graph, how to graph it. Okay, so we'll put the problem, and let's do it. So I will put it out. That's 87, sorry. So I want the function satisfies the following condition. Limit. So you read every word, try to make sense out of it. And whenever there is an asymptote, whenever the info tells you there is an asymptote, I want it to be told. The limit is plus infinity. And I want the limit to 0 negative of f of x to be equal to minus infinity. And what I want the limit as x goes to infinity of f of x to be equal to 1. And when x goes to minus infinity, I want the function to be equal to minus 2. So this is the conditions that I want the function to satisfy. And you guys will have to graph it. But let us analyze every word here. If they tell me that when x becomes close to 0 from the positive, the function goes to infinity. What does this tell me in terms of asymptote? What does this tell me? How would you explain that? I mean, do we have an asymptote somewhere? So when x close to 0, the function blows up. So what's going to happen? I don't know if my question is clear. 0 is vertical. Yeah, but I think you have the right idea, but let's write it in a better mathematical way. What does it mean 0 is vertical? 0 is a number. It doesn't really make sense. So what's the better way of writing that? What's a better way? Okay, still, this is better. I want something more. Not 0. What is the asymptote? What's the asymptote? The asymptote is a line. Right. It's the line x equal to 0 is a vertical asymptote. 0 is an asymptote. No, I don't know what you mean. A line is an asymptote. Okay, now that's better. Also, when x goes to 0, the function is blowing up. It means, again, I have an asymptote, which is the line x equal to 0. Now, what does this tell me in terms of an asymptote? When x goes to infinity, that's an end behavior. The function takes the value 1. I'm sorry, the function takes value very close to 1. So again, that tells me that I have horizontal asymptote. Horizontal, the equation is y equal to 1, is a horizontal asymptote. And when x goes to, again, that's an AND behavior. It means when x goes to minus infinity, y equal minus 2 is a horizontal asymptote. So I give you a minute to all of you to graph it, and then I want one to explain what they did, basically the way Elizabeth tried to explain it to us in Word. And we have to figure out how can I pin you down, guys, if you want to show me something. Are you guys drawing it? What would you draw first? If you are doing it, what would you draw first? Horizontal? Horizontal. So we have to draw those horizontal asymptotes. So y equal to 1, we do the asymptote in red, y equal to 1, that's 1. And that's telling me that, right, the function is here when x grows to infinity. And y equal minus 2 means the function is here when x goes to minus infinity. And then we have this line, that's an asymptote. And what do we know here? When we approach from the positive, it means when x is here, we write here because the function goes to plus infinity. And when we approach from the negative, it means here we go to minus infinity. And I think do we have a graph now? Do we have a graph? Okay, anybody would like to say it in words so we can get more things done? Anybody?
You're going to take the where it's at 0, where the vertical asymptote is at 0.
Positive or negative 0?
Start with the positive one.
Okay.
And then you're just going to bring it down, just run it along the asymptote all the way over there.
Around the asymptote. Please go, keep going.
And then that one, you just go up all the way to the left.
I have my graph. Okay, so it's not hard. It's just have to read the info, make sense out of them, and then when we do that, you know, graphing is, I mean, it's not easy, but what they're asking us is not hard. All right. Okay. Now I'll move to your other questions, which are from the review. So I think I printed the review. And please write your problem again because you confused me at the beginning. So which problems you guys had from the review? Please get them going quickly. Get going. 15M and 17A. So I'm marking down what you guys have. Okay, 15, that's number 15, M. And Chris wants 16A. And Patrick tells me 17A. Okay, we'll do that. Any other one from the review? Okay, so we go and 15M. Yeah, I did 15M, I got that. All right, so let's do every one of them. So I'll start with 15. I will put it up. I will write it up, and we keep going. And if anybody has any other questions, please put them up. So we need to find the limit as x goes to minus infinity of the following: 5x to the power 3 minus x squared plus 12 over 2x squared plus x minus 3. Okay. All right, so let's do that. Okay. So So first we analyze. You don't jump. You don't just say, okay, I factor. No, I divide. You analyze. You first analyze. So when x goes to minus infinity, my numerator, since x is very large, basically x cubed is going to take the lead and going to dominate the expression because it goes to infinity faster than x squared. So the numerator is going to become, let's see what happened to the numerator. When x goes to minus infinity, because it's x cubed, the numerator goes to minus infinity. And my denominator will do as well, but it will go to plus infinity. So I definitely have an issue. I have a very large number over a very large number. Anything can occur. Now, in this scenario, when you have a very large over very large, we use the trick of dividing. And so we divide numerator, denominator by divide numerator and denominator by x squared. Okay. As I said yesterday, you can either pick x squared or you pick x cubed. You have to pick one of them. It doesn't really matter which one, whichever you think you like more. So we divide and we do it a little bit slowly. So dividing, it means every term has to be divided. Every term has to be divided. Otherwise, the algebra is not right. So basically, we're looking now for a horizontal asymptote. That's really what we're looking for. We're studying the end behavior of the function. And so the limit, so give me the following: 5 minus 1 over x plus 12 over x squared, the whole thing divided by 2 over x plus 1 over x squared minus 3 over x cubed. And now we take it piece by piece.
Under the 12 should be x cubed.
Where?
Plus
oh,
12 over x.
Oh, sorry. Thank you very much. Thanks. Okay, so let us do it step by step. Next goes to minus infinity. What happened to the numerator? It becomes close to what? Help me out. This whole thing will become close to what?
0.
Why? Why 0?
Because it's 5 minus like an infinite decreasing number.
Keep thinking. When x becomes close to minus infinity, 1 over x becomes close to what?
0.
Right. Think about it. If you ever forget, just take numbers. You say, okay, 1 over 100. Okay, or like in this case, minus 100. It's a small number. 1 over minus 1,000. It's even smaller. Okay?
Yeah.
Are you with me?
Yeah.
Okay, so this one goes to where?
0.
0. What about this one?
0.
Oh, 0. So the whole numerator will become close to what?
5.
5. Absolutely. Okay, now what about the denominator? What about the denominator? When x goes to minus infinity, let's analyze every piece. This one become close to, quickly, 0 plus. This one become close to 0. This one become close to 0. 2 over large, this is small. 1 over large square, it's small. Minus 3 over large cube, it's small. So my whole denominator now is going to become close to 0. Okay. So what's going to happen to my whole expression? So you have 5 over something very, very small. So what is going to happen in this case? Not undefined. Why undefined, Austin? Anybody? Am I doing something that doesn't make sense? Oh. Okay. All right, what's going to happen? The limit doesn't exist when x goes to minus infinity. Why it doesn't exist? It's going to go to, it's 5 over something small. This is basically going to go to infinity. But the question, is it going to be the positive infinity or the negative infinity? When x goes to minus infinity, this term is going to be small negative. Okay. So it's 5 over, it's just going to basically go to minus infinity. Right. And I'm going to redo this problem to make it easy on us by dividing by x cubed, the numerator denominator. And there is a reason I will do that, because at this stage, 5 over something very small is not indefined. Something over something that goes to 0 is going to be plus or minus infinity. But if I want to know exactly whether it's to plus or minus infinity, I need to know, is the denominator going to 0, which is positive small or negative small? Positive or negative small. Otherwise, I don't know whether it's a plus or a minus infinity. That's really what the issue here. So I will do it by dividing by x cubed, because it will make the problem much easier for me. Or I have to sit down and start thinking here. If I start thinking here, whether it's the positive or the negative, it's going to be a little bit tricky, because I will have to take, so that's going to be the negative, so that's small. That's going to be the positive, because it's squared, and that's going to be negative. So it's not fairly clear in this picture whether it's the positive small or negative small. However, if I take the same problem, divide by x cubed, it's going to become much clearer. So this problem and then intuitively I will explain it to you. So in this problem, I'm going to take it, and I'm going to divide by x cubed, because it makes it much easier for us to figure it out. What did I divide by x cubed? I should have divided by x squared. Oh, why didn't you guys stop me here? All right. Okay, I'll do it. You guys should stop me. All right, so sorry, ignore it. I will redo the problem to make it much clearer for us. So we're going to divide numerator denominator by x squared, the highest power in the denominator, because divide by x cubed made the analysis a little bit harder. Okay, sorry about that. So let me redo it so it will be crystal clear. Divide by x squared is going to give me 5x cubed over x squared minus x squared over x squared plus 12 over x squared, divided by 2x squared over x squared plus x over x squared minus 3 over x squared. That's the highest power in here. So now there will be no confusion at all. So this will give me the following. Numerator will give me here, it's a 5x. This will give me 1 over x. This will give me 12 over x squared. Denominator will give me a 2 plus 1 over x minus 3 over x squared. All right, now we're basically done. So now when x goes to minus infinity, let us analyze every piece. The numerator will become close to what? Now we check this piece. 1 over x.
Middle term is wrong.
What?
It should be -1 because you got x squared over x squared. The 1 over x should just be -1.
Oh, okay. Thank you very much. So this stays 1 then. 12 over x squared will become close to 0. 5x will become close to what? Minus infinity. So my numerator is going to become close to minus infinity. What about my denominator? One over x, going to close to 0. 3 over x squared become close to 0. So my whole denominator is going to become close to 2. So I have minus infinity, very large negative divided by 2. Okay, this is going to be very large negative. Okay, so sorry about the confusion. I told you divide by x squared, I divide by x cubed, made the problem harder to analyze. And the problem is basically very simple. Okay, so we divide by x squared, we got exactly minus infinity. Now, intuitively, do we expect the minus infinity? And that's really where your intuition should help us. Intuitively, when x is very, very large, the whole denominator, this term is going to dominate. In terms, it means that when x is very large, the numerator will take values that are very close to the values obtained by 5x cubed. The denominator is almost taken over by 2x squared. So the ratio will be taken over by 5x over 2, and that's really at a very intuitive level. So when x becomes close to minus infinity, the 5x over 2 goes to minus infinity. So we expected minus infinity because we have a much larger power in the numerator than denominator. But tomorrow on your exam, I want the whole algebra, not the little piece like this. Okay. All right, so I'm sorry about this stupid mistake from my part. So we proceed to your other questions. I was wondering, should not be that hard. Okay, now we look number O. So it is the limit as x goes to 0 of, this is x, and this is 1 minus the square root of 1 minus x squared, okay? And again, analyze, because we may not have any issue. Sometimes we don't. So let us analyze. When x goes to 0, my denominator goes to 0. So already have an issue, but then it will depend on the numerator. When x goes to 0, 1 minus 0. So I have 1 minus 1. This one also goes to 0. So I really have a problem. The numerator is small. The denominator is small. Small over small could be anything. So that's what we called indeterminate. That's the word we introduced. And the idea is we have to do some algebraic trick. I mean, we have to really do tricks to be able to get rid of the scenario 0 over 0. So one trick we did, if you remember, we factored. That was one of the tricks we did. So whenever we have 0 over 0, we try to factor. Or sometimes, we couldn't factor, but we did take this issue, this problem before, and let us remember, what did we do? So whenever the square root, we trying to get rid of the square root. Okay, you remember what trick did we play? It's really a trick that you learn and then you use. Which trick did we use in this scenario? Anybody remember?
Isn't it like multiplying the numerator and denominator by the conjugate?
Yes, that's what we did. Yes, and this will solve the problem. Those are, as I said, those are tricks that you learn. It's not like, there are some very intelligent people out there that figured these things out. Okay, so that's really the trick in this scenario. And the idea is we want to avoid this scenario. We want to so much so we don't have that to deal with. Okay, now we are almost there in this problem. So this will give me the limit as x goes to 0 of. Now, this product is like A minus B if you want. You multiply it by A plus B. So if you multiply this out, you will get the A square minus the B square, which is this term. Okay, and you divide this by X times 1 plus that. Okay, of course, the idea is really to get rid of the square root. So we simply, if we almost down here, we'll get 1. This will give me minus 1 minus x squared over x times 1 plus 1 minus x squared. And as I repeat, my goal is not to have 0 over 0. That's really what my goal is. Now, 1 minus 1, simplify. I will have minus minus, that's in x squared, over x times that. Okay, so now I have x squared over x. Definitely I simplify by that, and I'll end up with this. So we keep simplifying till we can't do it anymore. How can I analyze? I did analyze what's happening when x goes to 0. This goes to 0, but that's not enough. I want to guarantee the numerator doesn't blow up in my face. If the denominator go to 0, I still have an issue. But it doesn't, because when x goes to 0, this term here is close to 1. My whole denominator close to 1. I'll have 0 over 1. It means this is equal to 0. All right, so this is a scenario, 0 over 0. We either factor or we play this trick, or we find common denominator, like one of the problems also I have on your, on your review. Okay, please ask questions as I move on. Okay, before we go on, when I did this, messed you up a little bit with the simple problem, I saw something on chat that I definitely would like to address before I take up the last problem. I had an expression like this. Okay, and when I asked what's the limit as x goes to 0 of 2 over x squared, I got an answer like it's undefined. And is it this undefined? What's the limit? That's a square. What's the limit of that? I want to make this sure. If I ask you about a limit, you're not plugging in a 0 in here. Remember, when we compute the limit, we don't care about 0. We care about value close to 0. So the limit here is not undefined. The limit here, when x goes to 0, and this is a positive 0, so this is positive small. This is going to be plus infinity, not undefined. Okay, so I saw somebody writing 0 undefined. It's not undefined. Positive small, it is plus infinity. And this is actually will help us in number part A, because we have to do all this analysis ourselves. So I'm going to now take problem A, which requires a lot of analysis. Okay. So I will do number 16A. Okay. So in this problem, I gave you a function. It's 4x squared over x squared minus 4. And my question is, I want the horizontal asymptote, I want the vertical asymptote, and I want a rough sketch, just like what we did at the beginning, 87, 84. So how intuitively the function is going to look. So first, horizontal asymptote. Okay, how do we find horizontal asymptote? Make sure you do not confuse the horizontal and the vertical. So the horizontal, those ones, really address the end behavior. So horizontal asymptote, you find the limit as x goes to plus or minus infinity of the function. That's what the horizontal is, the end behavior. Now, the vertical asymptote is basically you study what happened when the function is not defined. So these are the vertical. At some point, the function is not defined, and basically you're studying what's happening near that. And it's based, so vertical asymptote, you study what's happening, and they occur when the function blows up. Okay, so horizontal asymptote. Here, I'm studying the end behavior. So here I have to study the limit as x goes to plus infinity, and the limit as x goes to minus infinity. Okay. All right, so let's do that. This is hopefully not hard. So it's 4x squared over x squared minus 4. Again, we have infinity over infinity. We definitely have an issue. So we divide numerator and denominator by, now intuitively we should get 4, because this is 4x squared. When x is very large, you can basically drop 4 in front of x squared. So we should expect 4, but as I said, I would like you to do the whole thing. So I'm going to divide by x squared. So I will have 4x squared over x squared divided by x squared over x squared minus 4 over x squared. Okay, so this will give me what? The limit as x goes to infinity of, this is a 4 up here, this is a 1, minus 4 over x squared. So when x goes to plus infinity, 4 is 4, this will go to 0, so the whole thing give me 4. So this immediately, I know that y equal to 4 is a horizontal asymptote, okay? Now we compute the limit as x goes to minus infinity. And in those problems, both limits are the same, but they don't have to be the same usually. And in our situation, because we don't know a lot about how to work with limit, except the one I'm giving you, so I have a hard time to give you problems where the asymptotes are different from plus infinity and minus infinity. So that's really, eventually, I hope I will be able to do that. From minus infinity, again, I can do the same analysis and I get 4. So that will pick up my horizontal asymptote. So my horizontal asymptote, I have 1, y equal to 4 is my horizontal asymptote. And that's the end behavior. That's really what's happening here. That's what's happening here. All right. I keep this in mind because I will have to refer to every bit of knowledge I have. All right, now the vertical asymptote. I will rewrite the function clearly and then we analyze them. So this is my function. And this is 4x squared over x squared minus 4. Okay. And the question is the vertical. Now the vertical asymptote, they actually occur when my denominator is 0. So the vertical asymptote, the candidate, so this is what I call them, the candidate, or they usually occur when this happens. It means x squared equal to 4. It means x equal to plus or minus 2. So that's where the function is not defined. That's where the function is not defined. So now I have to study that. So now first I have to study. Is x equal to 2 is an asymptote? It means does the function blows up near x equal to 2? And does the function blows up at x equal minus 2? So first we're going to study x equal to 2. What do I mean study it? Okay, it means I need to find the limit from the right, and I need to find the limit from the left and make sure the function actually blows up. Because as you realized yesterday, sometimes we have this issue, but the function does not blow up. So let us analyze this. And I want the actual limit. Okay, so when x becomes close to 2, okay, the numerator is becoming close to 2, so squared 16. Okay, that's close to 60. Now the denominator, from the negative, x is becoming close to 2, but it's less than 2. That's crucial. So like 1.99. So when I square it, I'm going to have a number less than 4. So this is going to become small. That's important. Small. Is it a positive small or a negative small? Negative. Do you agree with Elizabeth? Because 2 is less 2, my x become close to 2 from the negative. It means x is really less than 2. So when I square it, I'm going to have something like, so if x is 1.999 and I square it, I'm going to get something a little bit less than 4. So this is less than 4 minus 4. That's going to be small, but it's a negative small. So now I have 16 divided by something fairly small, but it's negative small, not really positive small. So it's not undefined because I'm not putting 0 here. I'm putting something close to 0. I'll never put 0 here. I'm putting 1.99 square, 1.999 square. That's what I am putting, causing it to be minus infinity. So definitely we have an asymptote. X equal to 2 is an asymptote. Absolutely, because the function is blowing up in here. So if this is x equal to 2, absolutely an asymptote because the function is blowing up. That's really what a vertical asymptote is. Now from the positive, again, I have to analyze it. The numerator is not giving me an issue, so it's not infinity. It's not giving me any issue. The denominator is giving me, doesn't give me an issue. Now x is close to 2, but larger than 2. So x is 2.1. So x squared is going to be a little bit larger than 4. So this is going to become very small, but positive. So the whole thing plus infinity. So we are here, basically. And definitely is an asymptote. So my first conclusion, x equal to 2 is a vertical asymptote. No question asked whatsoever. Now, if we do x equal minus 2, and we have to analyze it again very, very carefully. So x equal minus 2. And you guys basically have your almost your calculator with you tomorrow, so you can really study this with the plug-in number. So x become close to minus 2 from the negative. Equal. Okay. Now I'll show you 2 ways of doing this. When x become close to minus 2 from the negative, the numerator, even if it's minus, when you're squaring it, that's going to be plus. So this is going to always become close to 60. All right. This is the problem here. When
I
x
have a question.
Yes, please.
Just very quickly, what type of number would the -2 to the minus side be?
This one?
Yes.
Okay, you tell me. This is minus 2.
All right.
Right? From the left, it means which values I'm interested in.
Oh, like -2.001. Would it be?
Minus 2, yes. Point. Keep going.
0.001.
Exactly.
All right.
Exactly, from the left. But now here's the thing. Stay with me. When I square this, because that's what I'm interested in here.
That becomes positive.
That's positive. Is it bigger than 4 or less than 4? Because I want to take 4 away from it.
It's bigger than 4.
It's bigger than 4. So the whole thing is going to become small, positive.
All right. Thank you very much.
Very good. That's
Yes.
for everyone. I mean, I'm glad you asked. That's for everyone. So that's what's really going on in my head. So now 16 over small positive, that's positive infinity. So you have to analyze. You have really to know what is really going on here. So now what's the limit? When x become close to minus 2 from the positive, and now we will do the same analysis by really thinking, what do I mean? So here, this is minus 2. It means I've never take, when you think limit, you never take minus 2. It's nonsense because minus 2 is undefined. Close to minus 2. That's the picture. So I am right here now. So what's the number in my mind? What number in my mind? Any of you? Just speak up, guys.
Negative 1.99.
Negative 1.99, whatever. and that's the one that you're going to square. So two things, it's going to become positive, and 1.99, when you square it, you're going to get a number less than 4. So this is really going to be less than 4, because you need 2 squared to get 4. So if you have 1.99, you have now something less than 4. So it means that this little piece right here is going to be small, of course, but it's less than 4, so this is going to be small negative. And this is going to be equal to minus infinity. So definitely, the function is blowing up near -2. So definitely, x equal -2 is a vertical asymptote. So I have two asymptotes at 2 and then -2, vertical ones, and I have a horizontal asymptote y equal to 4. Now I have to put everything together and make a rough sketch of, you know, the whole picture and see what you get. So I will, so I have this info and the other info I have, so I need to write it down. So what else do I have? I have the following. So I have this, I have that, and I will put this purple here because, and also I have y equal to 4 horizontal asymptote. Okay, that's what I have. These are the information. Now let us make a rough sketch. Let's make a rough sketch. I'm going to keep this paper in front of me, so I need some room here. Okay, and let us sketch very clearly. So what's really going on? So it's my function. Sorry. Okay, now what do I have? I have x equal 2, x equal -2, vertical asymptote. X equal 2, that's x equal 2, x equal -2. Those are my asymptote. Good. Y equal to 4 is my horizontal one. That's y equal to 4. And now a rough sketch, a rough sketch. I mean, we're not doing like a perfect one, but we're doing a rough sketch. Now, usually I like to pick up a value of the function to have a good idea. So I would like to know, what does the function do at 0? Just really to start building an idea. What's the value of the function at 0? Now, my original function was, this was my original function. That's what I'm working with. So at 0, my function takes 0 over -4, which is a 0. Okay, now, so at 0, my function is right here. Now let us pick up the pieces. This is asymptote, this is asymptote. And so we're gonna start somewhere in here because that's my vertical, and then are we gonna move up or down? I cannot decide till I go back here. Okay, when we get close to -2 from the negative, my function is blowing up. It means this is my vertical one. It's gonna blow up all the way here. So that's so far the picture. Now, when we're getting close to -2 from the positive, we're going to -infinity. So I am right here. Okay, and then there doesn't seem to be any problem till I hit the 2. Now at 2, again, I'm analyzing. From the negative, you know, from the left, it's going to -infinity, right here. So what do you thought? At 0, it's here. It's at -2 from the right, it's here. 2 from the left, it's here. So what's the function going to do? How am I going to connect them intuitively?
Parabola.
Exactly. I'm going to go something like this. Okay. That's the best I can. And I said this is a rough sketch. You know, eventually, you know, when we start studying derivative, we can have a perfect graph. But now we're really trying to do our best with the little info we have. Now, when I'm approaching 2 from the positive, my function is up here. And then horizontal asymptote is there. Okay, and we have a good graph. Now, of course, if you pick up your calculator, you should get something close to that, but I'm not really using it right now. That's not the point at this stage. Okay. All right, any other questions? Now, we did a lot of limit and asymptote today, which is fine, but remember your exam will cover everything. I mean, everything on your review. So I will fairly quickly. And please don't not be a minute late. I mean, I will be here early tomorrow. So I will be here at 10 to 8. So if you guys want to start at 10 to 8, you know, I'll start with you. Okay, so this is the review, and every aspect of the review will be presented. So, but for example, find the domain. So we should be able to find the domain of the function. Okay, it means the input that are allowed, so that spits out an output. So please make sure you can do all those problems. You will definitely, not definitely, I really don't know. So like you have a function, I would probably check you, can you do problems along those lines that I think we're heading toward those problems very soon, and they are crucial for me that you know how to do those, so I have to make sure you can do them. And then this has to deal with composition of function, which is again, we will need, so every aspect of what we're doing now is something I will need later on. So the composition of function, how will you write it? The exam is just here on Zoom. Yes, Neely, it's just here on Zoom. And as I said, if you guys like, if you want, I can start like a little bit early, like at 7:50. If you want. Do you guys want me to start early? Anybody has issues?
Yes.
Do you want me, yes or no?
Yes.
Anybody
Yeah,
else say yes?
that'll be fine.
What? Okay,
Yes.
yeah, all right, yes. Anybody say no? If one say no, I drop it. I mean, because it's your right. Okay, or you can write me email confidentially. You know, you don't have to put it up there if you really have difficulty with that. Otherwise, I actually can start you at 7:50. All right, so you will have composition. This is about taking a function and breaking it up, which is every aspect, as I said, I will need it very soon. So this is teach us how to break up the function. What else? How to find the inverse. I like those problems because they require algebra, which is, so I really like them for their algebra. So, you know, I mean, here I was marking problem that I said I will cover with you in case you didn't ask questions. Okay, so this is really a lot of algebra involved, and finding the inverse. Remember, it's just you finding x in terms of y. So you set y equal f of x, and you solve for x in terms of y. Okay, and then those I've tested you on your quizzes, and make sure go over the quizzes. Yes, absolutely. Skip to continuous problems, right? Absolutely. As I said yesterday, you will never be tested on something I don't talk a lot about it. And then solve question equation. You know, we've done this. You're still responsible for that. And those are mainly transformation, shift. You know, shifting to the right, to the left, up, down, and stretching, only stretching vertically. Piecewise defined function, we've done those. And then here is, I give you the graph and you guys find the function. I quizzed you on most of those things. And remember, you guys did well on this problem on the quiz, so hopefully you're fine. And then bunch of limit problem and asymptote. Austin's asking me about the continuity. You're not responsible for continuity. The only thing you're responsible for is 17a, up to here. Okay, continuity just take me half an hour on Monday. I'm not concerned about it. Okay, so you're everything up to 17a. 7a is included. It has nothing to do with continuity. It's just a limit. And I did a problem like this yesterday. All right, so good luck. And the solution to your quizzes are on Brightspace, except I think the quiz 3 that I'm going to write now and put it up. And if you know you get stuck and you have any questions, plus email me. All right, so tomorrow at 7:50, good luck for all of you. Bye-bye for now.